Every EC student hears that semiconductors are the future, but no one explains what it really means for you. So, in this episode, I speak with Mr. Kunal Ghosh, who has spent 15 plus years in the semiconductor industry. And today, we will be discussing why VLSI feels so overwhelming, what it really takes to break in, and if you're really serious about electronics career in the core side, this episode or this conversation will be a game changer for you. So, yes, the conversation is ahead. Thank you. So, first of all, Kunal, thank you for being here on such a
Mm.
short notice. And since I have been your student in VSD, it was far easier for me to contact you as well.
Of course, of course.
Right.
But it's an open invitation. Anybody wants to contact me, they can contact me 24/7. I mean, available for all of them around the clock.
Thank you so much.
Yeah.
You have been doing so much for, the EC students and particularly in the field of VLSI.
Hmm.
It's been 15 years, I think, that you have
Yeah.
spent in the semiconductor world, right?
Right.
So, again, now you are seeing by 2027 and, the government is investing heavily in semiconductors.
Hmm.
So, if a 20-year-old who is seeing this episode right now,
Uh-huh.
like, what would you tell them about this semiconductor shift in India? Because it's been a long time since, this VLSI domain is
Right.
there, but again, the growth and, the awareness of it is being spreading now. So, what
Right.
would
Right.
be your take, for the 20-year-old?
So let's look at it that way. The way I see at it is when I was 20-year old, I didn't look into what was currently trending at that point of time. The reason I chose VLSI, I chose semiconductors, is because I loved the field. That was one of the major reasons. Actually, it goes back way back towards the history or way I was brought up as a child. So my father is from Reliance Infocom. Right now you see Geo, but the setup, the background setup that you see, the entire system that
Right.
runs the networks. So my dad used to work over there, and he basically set up the entire electrical infrastructure uh, for an entire Infocom. It was called as Reliance Infocom. It was in Mumbai, Kansori. I did my internships over there, and my internship was on CDMA systems. And there was a point, you must have heard of it, that there was a point when CDMA technology was very popular, and there were a lot of lot of phones that was released on the CDMA technology. And my dad used to take me to these places, Reliance Infocom, where I used to see these big systems, the humongous systems that used to run all the networking applications.
Right, right.
So uh, I got an internship over there. I did my internship in networking, where we basically, let's say if you do a call, so how do you basically connect the call from the base station to the it goes from the user to the base station, from the base station
Hmm.
to the other user. So that entire network is something which we were working on that point of time.
Okay.
So the system part was already done, and then when we did a little bit of research, that what is that thing that is driving this whole networking systems, it comes back to, it boils down to chips. That's where the chips word came into the mind. That's how we learned about, or I discovered about chips.
Hmm.
Moment we that enlightenment can happen, that that the chips, and I'm talking about 2007, I'm talking about 2004, 3 4 5, that era where internet was not that strong. It is not as strong as that you see now. So chips and all that was very rare. If I wanted to know something about ICs or chips, the way I have to get information about chips is through books. We have to read a lot of books, like 200 pages books, to understand what
Obviously.
exactly chips
Because,
has. And
there were no tutorials
there
back
are
then
no
on YouTube as we
tutorials.
have it now.
Yeah, right, correct. So those are not there. So we read a lot of books. So through the books, we got a lot of information about chips, chip design. Then we got to know what is inside the chips, and also it all was driven from my own background, and that's why what you see right now, it's because it's been driven for long years. Though on paper it shows 15 years of experience, but it's been from childhood. The systems, the chips, and all these things got fascinated for us for from childhood.
Hmm.
Then when we researched, when I researched about how do you do detailed study about chip design, and what actually makes those chips, that's what we researched, and found out that there were manufacturing fabs, That's when we learned about Intel. Intel had got the first fab back in
Right.
1980s, 90s, somewhere in the US, and that's how more and more physics came into picture. That it is the physics is the one that drives the whole world. That's how we got to know about the physics behind the chips. And then we were looking for programs. So at BTech, when I finished my BTech,
Mm.
the BTech curriculum which was there, it didn't focus much on chip design, but it focused more on the electronics and telecommunications. That was my field.
Mm.
But the curiosity was there, that what is it that goes inside the chip, and how do you basically learn more about chip design, about semiconductors and all. So that's
Mhm.
where I started looking for programs for VLSI, master's program or any PG diploma programs for VLSI. That's what
Mm.
my search started. And parallelly, I had also given gate exam for masters. My rank was not very good. It was about 2000 something at that rank.
Oh.
So at that, and the toppers, generally the gate toppers, the top 100, they usually get IITs for master's program, for the 2 years master's program.
Right.
Then we still researched that what could be done with a valid gate. So for example, if you have a valid gate score, there are still many programs that is run across India which you can be a part of. So that point of time, we found out that IIT Bombay had a program called as Project Research Assistant. It's a 3-year program where they were looking for people who are not only good with technical skills, but they're also good with program management kind of skills. So
Mm.
when in the interview, the kind of questions that they asked were a little bit technical, a little bit on the management side, and how do you basically work while you earn, these two. So it was a
Okay.
three-year MTech Project RA program at IIT Bombay. I think more than 1,000 people had applied for that program as well, just because of the IIT Bombay tag name. I applied for the semiconductors word. That had been the curiosity within me. And that's out of I think 1,000, I think 10, 15 people got selected for that program, who
Mm.
had the similar kind of attitude where they had to work and earn together. That's the program that they were looking for. It was a 3-year MTech program. And
Right.
there my what do you say, my specialization is not into design. My specialization is into fabrication.
Oh.
I'm more into fabrication, physics, mathematics, light, optics, lithography, and all those. Whatever you see right now on the website, that is not my specialization. My specialization is manufacturing.
Oh,
so
wow.
uh, huh. Wearing all those clean rooms, getting inside the clean rooms, that is the specialization. And
Mhm.
from but unfortunately, at that point of time, there were not many jobs in manufacturing. I'm talking about 2010. So there was not much jobs in manufacturing, so I had to take a 3 months of program in design. And there was a course within IIT Bombay where it was done. And design jobs, there was plenty of design jobs within India at that point of time.
Mhm.
So that program actually helped me to get back to design. So now when I see, at that point of time, when we were doing VLSI, uh, uh, I never looked into whether the trend was there or not there. It was just that I wanted to do it, and that's why I do it. So a message for a 20-year-old student is to not get into VLSI just because it is the trendsetter. Get into it if you really like the field, because it takes a lot of time, lot of patience, lot of hard work, lot of, it's hardware is hard. When they say hardware is hard, they really mean it. And the reason for that is you have to stay long in this particular field, and unless you're able to give your 100% in this particular field,
Mm.
and there are pretty frustrating times in this particular domain. You must have seen it when you were debugging things,
Oh,
and how much
I
time does
I
it take.
don't want
Yeah.
to recall it.
Yeah, so there are those times available. There are those times in this particular field. And the reason we become special out of these, unlike a student, for example, if he is into software compared to uh, a person who's in hardware.
Mhm.
The reason the hardware, we say hardware is hard, is because a software, if there is a bug in the software, you can basically solve it through patches. It's a 1 month or 2 month of 2 month of work. On the contrary, if there is a problem in the hardware, you have to basically replace the whole chip. You cannot use the chip. You have to just throw it out. And
Right.
the time cycle is about 10 months of time cycle. So 10 months,
Mm.
you have to be constantly on the toes. So 2 months versus 10 months, that is what is drives the field. And me as a student, as a 20-year-old student, was ready to invest. my time in doing these things, and that's what got into the field. Now the trend is semiconductors, and it just got into the. I mean, maybe we were lucky to be at the right place at the right time, and
Hmm.
because we have been working for this field in for so many years, not knowing that it is going to be the trendsetter going forward. But we just did it because we loved this particular field. So even all engineers or freshers or anybody who's listening to this, if you don't love this field, it would be really tough to stay 15 20 years in this particular field. Then it becomes a little bit boring. You start to hate the field, you start to abuse the field, and that sends a
Right.
wrong message to the upcoming 20 years 20-year-old people. So better to stay away rather than getting into a field which you're not interested in.
So can we just take away the probably the takeaway which I would like to take from your experiences, that if you're passionate in VLSI, then
Yeah,
only you will be able to sustain in it.
you have to sustain. Yes.
Right. Then because of, if you're not passionate in it, or you don't have the urge to solve, or debug, or spend hours into it of the
Yes.
mastery, then
Right.
this field isn't for you, right?
Exactly. Yeah. That's
Hmm.
that's the way to put into it. And I think by this 10-week program that we did with IIT Gandhinagar, that must have answered all of these queries. What I'm trying to say, the amount of time that it takes, the debugging time it takes, the amount of dropouts that we had. So out of 3,500 participants, we had 16 to 20. There might be some reasons where there were exams and all, so that is completely acceptable. So we are going to figure out a way with the government, saying that can we do this program in some specific month of the year where there are no exams, and participants are absolutely free. Something like that we are going to figure out a workaround. But irrespective of the whole thing, 20 or 16 to 20 out of 3,500, that's about 0.5% who actually finish the phase one. And so that needs to be increased, and there is a way to increase. First of all, we have to build the program, because I heard from my team that there are a lot of submissions happening. It's
Mhm.
unfortunate that the exams came exactly at the center, so that's where there were a lot of dropouts. But we'll
Right.
take care of that in the next time. But the number could go to 4 to 5% very easily if the problems it happens. But yeah,
Hmm.
typically that is the number. 4% to 5% are the passionate people who would love to stay in this particular field for long, and
Right.
they were the ones who should be getting into this particular field.
Exactly. Again, like, even I was also the part of the exam
Yeah,
group
yeah,
because of
I
that.
saw, I saw. Yeah,
R-
I saw your
Right.
repo. Actually, the repo was pretty good. I mean, the progress that I saw in your repo, in the link that you have shared in your LinkedIn, there
Hmm.
was very good progress at till week 5 weeks. I saw people
Correct.
who shared the repo on the LinkedIn. I saw the repo. It was amazing progress. And then the break happened, the exams happened, all of this happened. So that might have accumulated. But again, we have to sustain through that field, and keep doing what we're doing.
Right.
But yeah, next time I think we'll also take care of this part.
Sure. Again, you had mentioned when you were speaking about your experience, when you were in our stage,
Mm.
they were MTech programs, right? Because
Yeah.
of it, you entered one of those programs. So could
Yes.
you mention a few of them now, at least, like because see, I'll tell you one thing. We are in BTech, and again, many of the tier 3 students are interested in the field of VLSI, just like how I am. But most of the times, what happens is people, they don't know how to use the open source tools and etc. Then again, they don't go for the path of building the skill,
Yeah.
but rather they go for the whole theoretical approach
Yeah.
first,
Yeah.
and through that, again, they try to give gate, but
Hmm.
many times luck plays a big factor in it.
Yeah. Yes. Yes.
Right. So again, what would be your suggestion for a person who has got a gate score, and again, but he can't apply for IITs, like the cream layer of the IITs for his MTech and VLSI. So what are his options?
So today there are, if not IITs, there are other options also. Like there is you have heard about CDAC
Right.
or NILIT. There are government organizations that run very good programs for the for masters in VLSI, and the whole point comes back to so everybody, now the way, these companies or IT, even IITs also look into, before even taking into candidates, they look into your profile, whether have you done at least few labs or something in semiconductors, so that that will basically tell them whether you're really eligible for getting an admission in CDAC or NILIT or any of the in fact IITs also run some programs where they offer you jobs as a project assistant, and initially the salary will be low, but the moment you enter into one of these IITs to as a project assistant, and then internally there is a way that you can convert your job to an MTech or a PhD program within
Mhm.
IITs. So on the top of my mind, what I see is CDAC, NILIT, they offer very good programs, and there are project assistant options that is available. If you're not getting an MTech, for example, admission. So there are project assistant jobs available in almost all of the IITs, but again they look for a technical skills. That is period. So the amount of time that you have to spend preparing for these interviews or for the gate or for anything, that the 10 weeks, for example, 10 weeks program that all of you did, that is non-negotiable. A program like that or a similar kind of program has to be done to, in fact, attend these interviews or attend these institutes. And they don't charge much. There are like either they are or completely free of cost, or they offer you jobs where they pay you and you do the work. And so there are multiple options like this. If you look into the technical positions offerings by IITs or triple ITs or CDAC and ILIT, I think the most interested ones will definitely find out a way to go there. For example, one of my students, in fact, he is very recent. Last year there was 3 4 students from one of the colleges in Chennai. They did one of our VSD squadron program, one of the VSD squadron program, and one of the NASCOM SOC design program. From there, they figured out a way to get into NILIT Calicut. I think he got a position over there as a job or as an intern, something of that sort. He figured out a way, but he went through the route. He went through the journey. At least he went through 6 to 8 weeks of journey with VSD. That the tough part. From there, he showed that he showed his project as a resume instead of his physical paper resume. He showed a project that he has done. He showed that project to I think NILIT Calicut, if I remember correctly. And then from there, he did a lot of internship he did a lot of work within NILIT in semiconductors. Then he submitted a paper in Taiwan. His paper got selected in Taiwan. And very recent. I mean, he's I think final year student. He was in third year when he started with us last year, and today he's in final year. And so there are many examples like this where they have chosen a different way, but there are a lot of options available with NILIT, CDAC, and these
Mhm.
companies to take you to the next level.
Okay, I see.
Yeah.
So, when we are thinking about masters also,
Hmm.
many of the people, like I said earlier, also they have this theoretical knowledge with them,
Hmm.
but there's no practical experience, or you could say no projects with them,
Hmm. Right.
right? And when we are looking at the job market right now,
Yeah.
many of the jobs, they expect us to have experience with us, like
Yes.
minimum, bare minimum of 2 years at
Two
least,
years. Yeah. Yeah. Exactly.
right?
Yeah. There is
There's
a.
one barrier, like, so
Yeah.
again, a student like me who is in third year or right now in fourth year,
Uh-huh.
how will he overcome this sort of problem, like the freshers problem? Getting into the industry itself is difficult. After when you get into the industry, growing there is dependent on them, but at least for being given an equal opportunity for us also would be important. But again, how would we able to achieve that?
So there's a history behind it. There is a reason that it has moved to 2 years right now. So if you look into 2010, when we graduated,
Hmm.
I had to do masters. Let's say after BTech, I had to spend 3 years in the field, and then only I was considered as a year experience of candidate in any semiconductor industry. So
Hmm.
even though you're a fresher, or even though you have spent, like, let's say, at least 2 to 3 months reading about theoretical VLSI. Currently, so okay, for example, let's take an example of let's say physical design flow, for example. So there was a time in 2007, 8, 9, 10, in those era, where knowing the physical design flow into detail, which took about 6 to 8 months of work, even if you know that much amount of flow, there was a job available for you in the market, because it was that scarce. It was that much of a problem. So what industry figured out, especially the top MNCs, they figured out that it is not feasible or reasonable to hire so many people or physical designers who are doing the same job. The job is very simple. The job is very same. You have to just run some commands and make sure the you understand what you're running. But hiring people for that job, it is not scalable. So the automation came into picture. We introduced a lot of CAD tools, a lot of automation. In fact, I was a part of Qualcomm, one of the Qualcomm CAD team, where the power routing, when you do the power and ground grid routing, it was quite of a manual work. So that part was completely automated by my team. So small pieces of things was getting automated in the physical design flow. Though a candidate in 2010, a candidate has to know what is physical design flow so that he knows what to automate. So going forward to 2010, 20, 11, 12, 13, 14, lot of automation scripts came into picture. So we have to we got rid of a lot of redundant tasks that was not needed. Now 2018, 19, or 2020, when this entire automation was quite pretty much stabilized, there was still a need that again, let's talk about physical design only. There was a need that I have to choose the right kind of constraints or right kind of flow switches. There were in the flow, there's a lot of switches. You must have seen in the open road or open lane
Right.
kind of thing. You must have seen a lot of switches. So there was a need that how do you basically find out a way that the system automatically decides what switches gives the best optimized PPA, power performance area, for a chip. So that part also again got automated. Now there are tunes like auto tuner, or there are tools with the proprietary tools which basically optimizes the whole flow along with the switches. So the 6 to 8 months of work, that training that I went through to learn just the physical design flow, that is now for people like the freshers students like you not only have to understand the physical design flow, that has to be done, but on top of that you also need to know how to basically find out a way to optimize the entire flow, using or get the values of the switches to get the flow in a correct in a fully optimized way. That is one of the requirement that all of you had to know. So that from 6 months, that is additional 4 months, you need to have a 1 year of work that you have to do. Now secondly, in the industry, when they hire you, they are basically expecting that you are productive from day one, because there are a lot of money riding with the service industry and with the product industry. And they're all running projects. They're all projects which is uh, which which cost a lot of money. So the projects that they are already getting, they have to deliver those projects at a certain time. And so for that, the industry requested back to companies like VSD, or institutes like IITs or NITs, that they wanted a talent who not only knew the flow. Of course, flow has to be needed. They also should know how to basically get an optimized flow, which is 10 months of work. Plus they also need people who actually understands the proprietary tools, which is again an additional 3 to 4 months of work. And they are ready on day one, which is again about 2 3 months of additional work, because the moment they put you in project, will be the industry is going to dump you with a lot of files, and you have to basically start working from day one. So slowly the experience level, that at my point of time was just 3 months to 4 months, because in my times, if I knew only the physical design flow, I was ready to get a job. But in now, it has slowly gotten expanding, and they want a candidate, they want somebody whom they can put directly day one on a project, and they can basically start running on the project. So the point over here, what I'm trying to say, we can't just do a flow and wait for a job. That is not going to happen. We can't just do a 10-week risk-fi India risk-fi program and just wait that jobs is going to come. It is not going to come, because 10 weeks is too less of a time from an industry point of view for them to put you inside the project. One of my students, like very recently, he did a program with us. I think it was a year and a half back. I think a year ago, last 2023 October is when he started with 2024 October, 2024 September when he started with us, and he recently got a job in Mentor. But he did the again 10 weeks program as we run the RISFA program. There was a very similar program at that point of time. He started 2024. He did the program, and from there he was continuously basically working with us on multiple projects. There were so many projects that we released from that day till last week. And just last week he was placed in Siemens as a CAD engineer. But
Okay.
the difference between what I see with him and the other candidates is we do the program. He did the program. He didn't wait. He kept on doing additional programs, building upon his skills, and made him. And he was brought into a level where he is easily, readily available for the industry to work on their projects. Compared to if I see many candidates where we have done a program and we wait for companies to call us, that is not going to happen. So there is a way where you once you do the 10 week of RISFI program, or again the phase 2 which is going to start next week. After that, there is a way that you can work with VSD. There are some projects that we are doing, live projects for the industry, and you learn those skills, and you do work a lot on some of the typical problem statements that we have. 1.5 years you keep doing it, and I think there is a place where industry definitely gives you a call. So it is a fortunate, or fortunate, it is a good point. It is a good thing for the industry that a lot of automation, a lot of AI came into picture, so that
Mhm.
they can so they save a lot of money on the huge talent that they used to spend. So that has definitely shrunk down. But now they need a different kind of talent who can outsmart them, and they can do the entire project. That kind
Mhm.
of talent is what industries is looking for.
Okay,
It's
I
business
understand.
finally. It's a business point of view.
Right, I understand that as well. But like because, but again, if we think from business point of view, everything you said, that stands true.
Yeah.
But again, if you see from our point of view, in colleges they don't teach anything.
Hmm.
Again, there is no hands-on experience in that. Everything is theory. Now I'm in third year, second semester right now.
Right.
So we are having this, CMOS VLSI design right now.
Hmm.
It's
Okay.
it teaches the CMOS concept, and we have the lab in which we are learning very log now.
Okay. Okay.
Right. So again, if you see in our syllabus also, VLSI is introduced in 3-2. Uh,
3-2 means
yeah, third year, second semester, that is.
third or second semester. Okay. Yeah. Correct. Yeah. It was the same in our case also. I mean,
Right.
in those days. Yeah.
Because see, you have also been passed out from engineering college, so you know that the syllabus is still the same. They have not
Yeah.
changed it.
Mhm.
And you see the industry's requirement is going up day by day, and they need, upskilled
Correct.
engineers in their companies as well to run the business well.
Right. Right.
Now, if someone who is interested, just like me, or a 20-year-old who is wants to transition into this industry,
Hmm.
what are the steps which you would recommend him to do so that at least he reaches to the level where where he can apply for the jobs and expect an interview call also? Because again, they as you said earlier that you need to be industry ready, but
Hmm.
if you see from a btech's point of view, that is difficult in this time right now in third
It
year,
is.
because
Yes.
due to internet we are having a lot of resources, but there's
Yes.
no streamlined resource for VLSI, especially
Hmm.
because there's a lack of mentors as well. You
Yeah.
would have seen that.
Yes.
So what would you recommend for a student like him?
So actually, third year might be a little bit early for because when we were also in third year, uh, at that point of time also the resources was not very much available. I always so the way we did our engineering is we always referred the standard books. We never referred the publications. There are some standard, for example, Wayne Tomasi for communication networks. If you see all these books that is there behind me, these are all basically standard reference book which I use for a BTech. So that's how in BTech. Okay, so if you look into from a technical standpoint, if you look into the semiconductors, it's nothing but a distribution of RC networks. If I had to prepare for semiconductors, and in fact, most of the top semiconductor engineers that you see across the globe, how they started was that they understand that the entire chip. If you look into the whole chip, it's nothing but it is a small combination of an R and C network. It's all
Hmm.
resistance capacitors. There was a subject in engineering. I don't know whether you have it or not. It's called electrical networks, where we use a book called as Valkenburg. So that actually teaches you how does the resistance capacitors, or in general electrical network actually work.
Okay.
A strong hold on the electrical networks gives you a very strong hold on the CMOS on the CMOS side. Now, I'm not sure how the CMOS is being, or CMOS or transistors are being covered as a part of the curriculum, but getting into the physics of it, getting into the current and voltage equations of an NMOS and PMOS, that is what drives the entire physical design. If you look into the physical design flow, that's what drives the entire physical design. So getting to know about the mathematics and the physics part of the transistors, that gives you a second level of edge. That itself will take you about 6 months of work. So within 3 months, getting to know that if somebody knows if somebody knows VLSI in a span of 3 to 4 months, that's something which industry also knows that it is not possible, because he or she has to go through this flow to better answer the interview, the questions that is basically right now. And right now the interview questions are getting smarter and trickier. They no more ask you, they don't ask you about the flows and tools and all, because that's eventually going to change. They mostly stick to the fundamentals. They stick to how good are you with your physics, how good are with your mathematics and electrical networks, RCs,
Mm.
CMOS and MOS. So they mostly look into the into this particular fundamentals, because we and industry, we all are aware that tools are going to change, the flows are going to change, and there is a way to learn those flows very easily. And that's not a big deal, because in my days it was a basic PD flow where we have given 10 lines of scripts. Now that part also has been automated by the GPT prompt. So things have changed a lot, but what made us stick to this particular field is the knowledge of the entire device physics and the RC networks.
Mhm.
Moment you put in your resume that you have done, you have spent at least 3 to 4 months of an RC network project or a CMOS device physics projects, that adds up a lot of value, because my resume had got two physics projects. One is the manufacturing that I had done in as a part of my MTech project. Second, there was a design device physics and design project as a part of my curriculum. So these two projects added a lot of value. And the third project was the physical design project, which again, that was a what do you say, a cherry on the cake, where the third project, it was just one line in my resume saying that I've done physical design on Synopsys tools at for this particular project. But on the top of that, on the top of the resume, Qualcomm, my first job was in Qualcomm. They clearly got the point that he understands device physics, he understands mathematics, he understands the networks, and then is
Mhm.
applying for a physical design job. So that basically added a lot of value. To do all of this, it takes minimum of 10 months to 12 months, or at least 15 months of work. I mean, 3 months doing a NDRS5 program versus doing something on top of it and making sure the fundamentals are correct, that takes at least 15 months of work. If this comes in your resume, I think there's nothing but basically stopping you. So for
Mhm.
20 for anybody who is in third year or final year, I think there is still, you still have good amount of time to complete, the at least the fundamentals part, where we talk about networks, device physics and mathematics. If these three are strong, because this involves a lot of coding and programming also. For example, if you want to simulate something, you have to code your drain current equation, or threshold voltage equations. You have to basically code it. A lot of programming comes into picture. That
Mhm.
also gives an edge to you, that you also know programming, and that's a very important part in our field. So
Right.
running a flow versus automating it, and running script to automate this whole thing, it also adds a lot of value in your resume. So this thing, this particular journey that I just explained, that takes 12 to 15 months of work. So participants who are in third year, you have fourth year semester one, semester two, third year semester two. Whoever are in third year semester two, that's a great point to start at least this part of the work, and you will see a change within yourself. And the moment you do RC networks and you create a data repo and post it online, you do a device physics project, code the whole thing in let's say basic C program or C++ program, and you code the drain current and show them, okay, this is what I've done on a
Mhm.
GitHub repo. So all these things, it adds up in the next 1.5 years. and you will see automatically a change. I saw the change in many, including myself and including some of my people who got some of my students who got placed in recently got placed in Mentor. He used to display a lot of his work, not Mentor, sorry, Siemens. He used to display a lot of his work in LinkedIn and GitHub. So all of this basically adds up. Finally, at the end of the day, at the end of the 15, 20, 15, 16 months, you will definitely see how people are approaching you, how people are talking to you. And this question, you will be able to answer your juniors in the same way that, okay, this is what you did and this is what works. It's a proven success formula. It's a
Hmm.
very pretty much proven. So you can basically propagate the same thing to your juniors, but you have to start it. Somebody has to start it to showcase your success journey to your juniors. So maybe you would be the one to start this particular journey, and you can propagate the same thing to your juniors. Okay, this is what it should be done.
Right.
Yeah.
Surely. Um, One important question which is on my mind when you explained, the part is people often tend to read fundamentals, including me.
Hmm.
Since you have told, you could start from now in the end of 15, 16 months, you
Hmm.
will see a new version of yourself, who is much more smarter and, industry ready, you could say, in terms of fundamentals.
Yeah.
Right. But again, when we just tend to read the fundamentals, but we don't see the, how do we apply in,
Hmm.
real world, that aspect. Like how can we achieve, that mindset where, when whatever we are reading in theory, we are applying it in real life as well, on the
Yeah, so
projects.
so this 15 months of journey includes that you need to code what you're saying. Start coding of whatever you're reading. So let's say an example of a drain current. So you have this huge equation, ID equal to VDS square, VD minus VDH square, that whole long
Right.
equation for the saturation current. Try to code that in C and see what you get. You will get to know a reason that why we have models like BSIM models and all of it. The reason to have a BSIM models is because there is a fundamental accuracy issue that you might get while coding it in C. While that's the reason why ngSpice tools was built using BSIM and other models. So when I say 15 months of work, that is, I'm talking about hardcore coding by yourself. That's what we did. We used to There was a subject called as numerical techniques and digital signal processing in our BTech.
Right.
DSP, DSP, and numeral techniques, where we had this Fourier transform or Taylor series, that fast Fourier transform FFT. Then there was a Taylor series, the whole thing. So all this, when we started coding all those things in real world in using C or C++, that's where we saw that, okay, it does make sense that these are the kind of signals that are being getting used in a chip, on a chip design. So the moment you start coding this and start publishing your results on a GitHub and on LinkedIn, that's where you see a change. But theoretical might not be very just reading the concepts might not be very helpful. And plus, it is something which you have to do outside your college hours, because during the college hours, I don't think so. There's a lot of theory that is being conveyed in the lectures.
Right.
And these things are something which I also did outside my college hours, because again, the colleges, the professors were good, but they are again, they are tied up with a lot of work already. And then they cannot, I think, monitor each and every how each and every student is doing. So it's something comes to us, because finally the job, finally I needed the job. I need to work in this particular field. So it is me. It comes from me. I have to be the one who has to take up this particular subjects, code it on my own, and display it on my GitHub. But it's the responsibility boils down to me. And
Hmm.
if I don't do it outside the college hours, nobody will do it for me. So it all starts from you, basically.
I understand. Right.
Yeah.
Since, it starts with us, right? So again, there's a lot of wisdom in this episode, but lastly, what I would like you to, answer is,
Hmm.
imagine, you are speaking to everyone right now. Everyone is a
Hmm.
20-year-old, an
Yeah.
ECE student, who is at his beginning stage and, trying to get into the field, VLSI, or, any domain in VLSI, you could say.
Right.
What would be your message to them as an, ending note of this episode?
So as I, the as we said that when there are quotes made like hardware is hard, and now in the last 1 hour I just explained why it's not the easy way to go forward.
Hmm.
So if you listen to the journey that we just discussed a few minutes back, where it all started from me, my from the way I was brought up in my whole environment. There was a lot of hardware, there was a lot of things that I had, and I didn't join semiconductors because it is going to be trending in 2030. I didn't even knew what it is going to be in 2025. I was in 2007 that point of time. So I didn't join a field because it was going to be trending. I joined it because I loved the whole thing. And similarly, there are if let's say if somebody understands what VLSI is, and but he need not be he needs to know something of everything, but there is one particular field which really excites him. And it is okay that might be a non-popular field. For example, there is a field called as formal verification. I mean, that is totally underrated, but that's the most important, one of the very important fields in our semiconductors. But that's very
Hmm.
underrated because it's not marketed. There is not very much marketing on formal verification kind of field. There is very less marketing on the layout front. There are so many things that could be done in the layout front, but there's not very much marketing that is done in the layout front. There is so much thing that you could done that could be done in the circuit side, but not very much promotions or marketing been done on the circuit side. So there are low hanging fruits in semiconductors also. Not physical design is just one of the very popular area, because that actually drives the whole chip design flow. But there are low hanging fruits which basically you can target and see whether you really are interested in that particular field or not. Don't worry what happens 20 years down the line. I mean, 20 years or 30 years, whether this field is going to be trendsetter or it is not going to be trendsetter. That's something is not in our hands. What is in our hands is we love the field, and we give our 100% to this particular field. Rest we just leave it to our luck or our fate, what it is going to happen. Edge AI will happen. AI is going to pick up, quantum computing, all of it are going to come. There is nothing that is going to stop it from coming. But in that bracket also, there must be some way, there must be some path for you to be getting connected to those fields. But you have to be really interested in that particular field, or really passionate to work on that particular field 24 cross 7. I mean, if you look into a journey of an entrepreneurs, for example, the semiconductor entrepreneurs,
Hmm.
Saturday Sundays doesn't even count for us. I mean, there is some or the other thing has to be done on every day. uh,
Right.
uh, and we don't feel as a pressure, because we love what we are doing. So it is kind of a joy. It is kind of the work is a break for us. So don't go by the trend, go what you love. That is the only way to grow in this particular field, else you'll find it very boring.
Right. Thank you everyone for tuning
Yeah,
in the episode. That is Kunal.
yeah, thank you
I'll
thank you
end
so
here.
much.